Assalamu alaikum everyone. Today we will start problems of unit number 3 dynamics class 9th. Let's see the statement of first numerical 3.1. A force of 20 Newton moves a body with an acceleration of 2 meter per second square. What is its mass? So in the given data, the force of 20 Newton and the body was moving with an acceleration of 2 meter per second square, and we have to find the mass of the body. Here we have used Newton's second law of motion. F is equals to ma. To calculate the mass, m is equals to force divided by acceleration. Now putting the values, 20 Newton divided by 2 meter per second square. As we know, the Newton is equals to kilogram meter per second square divided by 2 meter per second square. M is equals to 10 kilogram. Let's see the next numerical 3.2. The weight of a body is 147 Newton. What is its mass? Take the value of G as 10 meter per second square. So in this numerical, first enlist the given data. The weight of the object is 147 Newton, and additionally the information was given to us that G is equals to, the gravitational acceleration is equals to 10 meters per second square. If this information is not available to you, you will have to consider it 10 meter per second square. And what we have to find? We have to find the mass of the body, m. So as we know that weight of an object is equals to mass multiplied by g, because weight is the force with which the earth pulls a mass towards its center. It is equals to mg. To calculate the mass, W divided by G. After putting the values, 147 Newton divided by 10 meters per second square, m is equals to 14.7 kilogram. Now let's see the problem 3.3. How much force is needed to prevent a body of mass 10 kg from falling? First we have to enlist the given data. The mass of the object is 10 kg, and we need to calculate the force to prevent the object from falling down. Consider this box as an object. Earth is pulling this object in the downward direction with the force W. That is equals to mg. If we want to prevent this object from falling, we have to apply equal and opposite force to the W, that is F, in upward direction. We have to find the weight of the object, and then the force that we want to calculate is equals to the weight of the object. To find the weight of the object, W is equals to mg. As you know, the value of the mass is 10 kilogram multiplied by g, which is the gravitational acceleration. Its value is 10 meters per second square. So weight of the object is 100 Newton. This is the force with which Earth is pulling the object towards its center. To prevent the object from falling, we have to apply same force in the upward direction. So the force needed to stop the object from falling is equals to W, and it is equals to 100 Newton. Now let's see the numerical 3.4. Find the acceleration produced by force of 100 Newton in a mass of 50 kg. In the given data, the force is 100 Newton and the mass of the object is 50 kg. We need to find the acceleration produced in it. So we have to use Newton's second law, F is equals to ma. To calculate the acceleration, F divided by m. A is equals to 100 Newton divided by 50 kg. A is equals to 100. As we know, Newton is equals to kilograms meter per second square. So divided by 50 kg will give the answer of 2 meter per second square. The numerical 3.5. A body has a weight of 20 Newton. How much force is required to move it vertically upward with an acceleration of 2 meter per second square? In the given data, the weight of the body is 20 Newton and we have to move it in the upward direction with an acceleration of 2 meter per second square. To move the object in the upward direction having a weight of 20 Newton, how much force is required? Consider this box as an object whose weight is 20 Newton. The weight is acting in the downward direction and the reaction force on this object is acting in the upward direction, R, that is equals to the weight of the object, which is equals to the 20 Newton. Now we have to calculate the additional force with which we move this object in the upward direction with an acceleration of 2 meter per second square. To calculate this, first we calculate the mass from the weight of the object. So weight is equals to mg and mass is equals to weight divided by g, which is equals to 20 Newton divided by 10 meters per second square is equals to 2 kg. The mass of the object is the 2 kg. To calculate the acceleration, to calculate the force that produces the acceleration of 2 meter per second square, we use second law of Newton. F is equals to ma. F is equals to 2 kg multiplied by 2 meter per second square. F is equals to 4 Newton. This is the additional force that is required to produce the acceleration of 2 meter per second square in the object, in addition to the reaction force that is already 20 Newton. So total force that is acting on the object is equals to F is equals to normal force plus force required produce acceleration. Normal force is 20 Newton and force required to produce the acceleration of 2 meters per second square is 4 Newton. So the total force is 24 Newton. That's all about these numericals. If you understand these numericals, share these videos, like these videos, and subscribe my channel.